Hi Year 10 Mathematics 5.3 students. Today we're continuing on with the topic of probability and we're learning about Venn diagrams. So sometimes the results of an experiment involve overlapping categories or events. For example, a TV station might be collecting statistics regarding whether or not a person watched cricket or tennis or neither over a certain period of time. It can be very helpful to organise the information into a Venn diagram. So probabilities can be easily calculated from these types of diagrams. A Venn diagram uses overlapping circles to show the relationships between two or more sets of outcomes. It illustrates how all elements in the sample space are distributed among both events. So we have some examples of what the Venn diagrams look like here. So all elements belong to both A and B. So when all elements belong to both A and B, it is this coloured in bit here, so where the circles overlap. So all elements that belong to either events A or B. So it's really important to note this or here means that it can be to both events. So it's all of this bit here. So when you see or, it's all of it. When you see and, it's just that little bit in between. We also have that the two sets A and B are mutually exclusive if they have no elements in common. So mutually exclusive means that two events cannot both occur at the same time. And finally, for an event A, the complement of A is A dash or not A. So we have already learnt by finding the complement of an event that P of not A or A dash equals 1 minus the probability of A. Let's have a look at some examples. So consider the given events A and B that involve numbers taken from the first 10 positive integers. So what we want to do is we want to first represent the two events A and B in the Venn diagram. So how we're going to do this is we're going to have to write the numbers in the Venn diagram where they belong. So set A is the elements 1, 2, 3, 4, 5, 6, and set B is 1, 3, 7, 8. So 1 occurs in both of the in both of the sets. So we're going to write 1 in where the overlap happens. So where A and B overlap, because it occurs in both A and B. Now the number 2, it occurs in only A. So we're going to write it over here in the part of the Venn diagram of the A circle that is only A. 3, it occurs in both. So we are going to write that in the overlap part. 4, that occurs in only A. 5 occurs in only A. 6 occurs in only A. 7 occurs in only B. And 8 occurs in only B. But remember, we're considering the events A and B that involve the numbers taken from the first 10 positive integers. That means we have 9 and 10 that don't occur in either of these sets. So we are going to write them off to the side here. Okay, so part B wants us to list the sets. So we want to list the sets A and B. So that's where the overlap is. So A and B is going to be the set. We need to do our curly bracket. It's the bit where our overlap happens. So it is this bit here. So it is going to be the numbers 1 and 3. So 1, 3 is the set A and B. Now the set A or B is going to be the whole kit and caboodle. So it's the whole, whatever's in A and whatever is in B. So we're going to write that out. So it is 1, 2, 3, 4, 5, 6, 7, 8. So it's everything in A and everything in B. So these numbers are either in A or B, or they're in both. So I'm just going to write that off to the side. And the end one is only A and B, which is both. Okay, now we want to look that if a number from the first 10 positive integers is randomly selected, find the probability that the following events occur in A. So we want to find the probability of A. So to find the probability of A, we need to work out how many numbers are in A, and then we need to put that over our total number. So it's sort of like our relative frequency, which we did last lesson. So if we look back up, in A we have 1, 2, 3, 4, 5, 6 numbers in A over a total of the first 10 positive integers. So it's 6 over 10. So we're going to write it as 3 over 5. Then we want to find the probability of A and B. So there's only 2 numbers in A and B. That's our pink part. That's our numbers 1 and 3. So the probability of A and B will be 2 over 10, which equals 1 over 5. And the probability of A or B is either A or B or both. So it's all the numbers in the green bit. So we have 8 numbers there. So it'll be 8 over 10, which simplifies down to 4 over 5. And just remember, you always want to simplify your fractions where possible as well. So then finally, D, are these events A and B mutually exclusive? Why or why not? So let's just start off with the sets A and B are, and we're either going to write not mutually exclusive or they are. So we have a look up, we can see that we have numbers in both A and B, and we have numbers that occur in both. So for the sets to be mutually exclusive, that would mean that they don't contain any of the same numbers, so that they're circles on their own and they have no overlap. But the set A and B contains at least one number the same, so they have the 3. So A and B are not mutually exclusive because 1 and 3 occur in both. And so we've stated that they're not mutually exclusive, but we still need to explain why or why not. That's an important part of the question. So we go since, oops, what's going on there? Since there are numbers inside A and B. So because there's those numbers inside both of them, that's why it's not mutually exclusive. Moving on to example 2, we have from a class of 30 students, 12 enjoy cricket, 14 enjoy netball, and 6 enjoy both cricket and netball. Our first example is to illustrate this information on the Venn diagram. So I've got a Venn diagram already pre-drawn up for me. So what we have is, we have 30 students in total. We have 12 enjoy cricket, 14 enjoy netball, and 6 like both cricket and netball. Now, if we were to add 12 plus 14 plus 6, we're going to get a number larger than 30, and we only have 30 students. So what we need to do is we first need to place the 6 in the intersection, so in this bit here, because they like both. They enjoy cricket and netball. And then we need to work out how many only like cricket and how many only like netball. So because the 12 that enjoy cricket include the 6 that enjoy both cricket and netball, to find out how many only enjoy cricket, we have to go 12 minus 6. And 12 minus 6 is 6. And then to work out how many enjoy netball, we have to go our 14 minus 6. So when we go 14 minus 6, we get 8. So the reason being this is because these 6 in the middle here, they enjoy both cricket and netball, but they're also counted in the 14 that enjoy netball and the 12 that enjoy cricket. So then you're thinking 6 plus 6 plus 8, that's only 20. We have 30 students. So what about the other 10? So the other 10 like must like neither. So we write them out on the side and in one of the bottom corners, and that just means that they like neither cricket or netball. So now we want to state the number of students who enjoy netball only. So they only enjoy netball. They don't enjoy cricket. So it's just going to be this 8 here. So 8 students only enjoy netball only. And then we want to state the number of students that enjoy neither cricket or netball. So that's our 10 down here. Then we want to find the probability that a person chosen at random will enjoy netball. So in this case, we don't care whether they like netball or cricket. So we know that so we're trying to find the probability of netball. So we don't care whether they like netball and cricket or they just like netball. So we were told in the first place that 14 people like netball, will enjoy netball out of the 30. So we're at 14 over 30. Put that into a calculator. See if it can simplify down, and it can, to 7 over 15. Now we want to find the probability that a person chosen at random will enjoy netball only. So the probability of only netball. So that's going to be those 8 people back up here that only enjoy netball. So, and because they don't enjoy cricket. So 8 over 30. Put that into a calculator and it simplifies down to 4 over 15. And finally, we want to find the probability of both cricket and netball. So that's the pink part where they intersect. So the 6 students like both cricket and netball. So it's 6 over 30, which simplifies down to 3 over 15, which simplifies down to 1 over 5. And that is the end of the theory notes. Hopefully that makes sense and reinvigorates your mind on what Venn diagrams are.